Machine learning, according to Tom Mitchell, the prescribed definition for this machine learning is a computer's program is said to learn from experience E with respect to some class of task T and the performance measure P. And if its performance at a particular task T as measured by P improves with experience E. So there three important elements are there here, that experience, task and then the performance. So when we map this particular definition to a particular statement, let us take the example of a spam detection. Okay, there in the spam detection, the agenda is means we are going to predict, or we are going to classify the emails as spam or ham, that is spam or not spam. So that is the given task for a particular machine learning, and watching the labeled emails as spam or ham is the experience. So there will be a difference of spam emails and normal emails. So watching the labels of that spam emails and normal emails is the comes under experience. And the next one is the number of emails correctly classified as spam or ham is the performance. And after watching this labeled emails, if our machine learning algorithm correctly classifies spam as spam and if it is not ham as ham, then it is going to measure the performance. So these are the three important elements for a particular machine learning, that is performance, task and improves with the experience. This is the prescribed definition of this particular machine learning program as per the Tom Mitchell. And coming to this AI learning models and feedback based classification, based on this feedback classification, AI learning models can be classified into 4 different types. One is supervised learning, unsupervised, semi-supervised and the reinforcement learning. These are the 4 different types of learnings that comes under feedback based classification AI learning models. Let us see in depth one by one what are these 4 types of machine learning. See here, coming to the definition of these 3, first I will discuss about supervised, unsupervised, reinforcement, then I will discuss what is semi-supervised machine learning. So supervised learning is a method in which we teach the machine using the labeled data. It's like a classroom teaching. Okay, we will feed them some input and accordingly it is going to produce the output. And then coming to the unsupervised, in unsupervised learning, the machine is trained on unlabeled data without any guidance. Means we are not going to give any labeled data, we are going to give the input, no labeled data. This is unlabeled data. It is something like this. And coming to the reinforcement learning, it is totally different with the supervised and unsupervised. In reinforcement learning, there will be an agent. He is going to interact with the environment by producing some actions and discovers errors or rewards. Okay, errors are rewards. That means if it wins, if I take an example of a particular game, if in that game, if a particular agent wins, definitely is going to get the rewards or else he is going to get the punishment. That is what we say, that it is going to discover errors or rewards. So supervised is we are going to feed the labeled data. In unsupervised, we are going to give the unlabeled data, but whereas in reinforcement learning, an agent is going to pursue the environment and take actions. At last, he is going to get the rewards or punishment. That is what how we define these 3 algorithms. Okay. Then problem type. For what problems will use supervised, unsupervised and reinforcement learning? Supervised comes under 2 problems, one is regression and other one is a classification. And unsupervised, there will be an association and clustering. And reinforcement learning, it is different when an agent wants to interact with the world and he wants to win some game, then it comes under the reinforcement learning. So I'll explain in the further slides what are these different types of problems with one example. So for these problem types, you'll use supervised, unsupervised and the reinforcement learning. And coming to the type of data, already told you, supervised learning, we are going to give the labeled data. That is, we are going to feed the cat of for a cat, these are the particular features and the same will feed to the algorithm, and algorithm is going to classify whether the particular thing is a cat or not. Whereas in unlabeled data, just we will give the cat itself as the input. We don't define any features, but the algorithm itself has to find whether that particular thing what we have given is a cat or not. That is what unsupervised. And coming to the reinforcement, there will be no predefined data, either labeled or unlabeled, it is different. So when you see here, agent, he is going to pursue the environment, take an action, then he is going to get the reward or punishment, and accordingly he will change the state. So this is different. There will be no predefined data. It comes to the reinforcement learning. Next, training. Coming to training, supervised learning, yes, definitely we require the external supervision. And whereas coming to the unsupervised learning, there is no supervision is required. And even coming to the reinforcement learning also, no supervision, just trial and error method he'll use in reinforcement learning. And coming to the aim, if it is a supervised machine learning, we are going to forecast the outcomes. Outcome of a particular variable is the aim of a particular supervised machine learning. Coming to the unsupervised, it is going to discover the underlying patterns. It itself is going to discover the underlying patterns, and accordingly it will produce the output. And here in reinforcement learning, it is learning series of actions. Series of actions he will learn, and accordingly he is going to get the reward or punishment further. And approach. In supervised learning, you can see here we are going to map the labeled input to the known output, and we are going to train the model, and then we are going to get the known output as the output. This is the approach of supervised learning. And coming to here, it is unsupervised, understand patterns, and it is going to discover the output. That is unlabeled input we are going to give, and from that unlabeled input, the unsupervised machine learning algorithm explore patterns and trends, and accordingly it is going to give the output. That's why here we call it as the actual output, here we call it as the known output. That is what the main difference between supervised and unsupervised machine learning. And here coming to the reinforcement learning, here we will always follow a trial and error method. Yes, we enter into this particular game, at somewhere you will have a hurdles, and the next time you won't follow that particular path. Why? Because we already known that there is a hurdle and will take the other path. That is what the series of actions and states it will change. At last he is going to reward the game. That is what reinforcement learning. And coming to the output feedback, from known output just directly we are going to get the feedback, and whereas we'll get the feedback of what the labeled input we have given, yes, directly feedback we are going to get in supervised learning. Whereas coming to the unsupervised learning, there is no feedback. Okay, just directly as we are getting the actual data, there is no feedback. But whereas coming to this reinforcement learning, we have a reward system. Yes, of course, if you win the game, you are going to get the rewards as +1, and if you lose the game, definitely you are going to get it as a -1 or 0. That means that is just like a punishment. So definitely there will be a feedback system will be there for this, even this reinforcement learning. Then the popular algorithms coming to supervised machine learning, we have a linear regression, logistic regression, SVM support vector machine, K nearest neighbors, and random forest. Whereas coming to the unsupervised, we have 3 algorithms like K means, a priori, and C means. And coming to reinforcement learning, we have 2. One is Q learning, one is SARSA, that is state action reward state action. So these are the 2 popular algorithms that comes under reinforcement learning. And coming to the applications, so many applications are there, but few are mentioned here, like risk evaluation, forecasting sales. This risk evaluation comes under classification, forecast sales comes under regression. This recommendation system, anomaly detection, this comes under clustering, and this comes under a priori. And coming to the reinforcement learning, the applications, self-driving cars is one of the best example for this reinforcement learning, and even gaming also. These games we'll generally see online that will be implemented with the help of this reinforcement learning. And then here a simple example, problem statement, like study a bank credit data set and make a decision whether to approve the loan of an applicant based on his profile. Now we have to approve the loan for a particular applicant based on his profile. Okay, if it's for that, this particular approve loan or not, yes or no. So for that yes or no discrete output comes under classification. So definitely this particular problem statement comes under classification. So we are going to use any of the classification algorithm. Here simply I mentioned KNN algorithm. So it will give us the output as whether to approve the loan or the reject the loan. Then comes to next use case, just to establish a mathematical equation for a distance as a function of speed. So you can use to predict distance when only the speed of the car is known. Here they mentioned predict. Prediction is nothing but it comes under supervised learning, but here the problem is comes under classification or regression is the important one. Prediction, we know that there is no doubt it is a supervised, but here is we have to identify whether it comes under regression or classification problem. Yes, of course it comes under regression. Why? Because here function of speed, okay, distance, as depends upon the speed, the distance you travel and the time you have taken may vary. So definitely it comes under the regression. So the only one regression algorithm what we have is the linear regression algorithm, and it is going to predict the distance when the speed of a car is given. So when you provide a speed of a car, definitely it will give you the distance, how much you are traveling. Okay. Then use case, other use case 3, let us define one more problem statement. To cluster a set of movies either good or average based on their social media outreach. Now there are set of movies are there, you have to cluster it into whether it comes under good or average based. So the name itself cluster, you should identify that it comes under unsupervised learning. So cluster means grouping. We are going to group a good movies into one cluster and average movies into other group. Okay, so that's why we are using a K-means algorithm. So popular movies it comes under good, and non-popular movies it comes under average. This is what is this particular problem statement. Next one, to perform basket analysis by finding association between items bought at the grocery store. Again, by seeing this problem statement, association, when you see a word association, definitely it comes under unsupervised, and but coming to unsupervised, it's not related to the clustering, it's related to association. So compulsory we have to use association rule mining or simply a priori algorithm, and then we are going to perform the basket analysis. This is other problem statement. And next, yes, by seeing this you have to identify that it comes under reinforcement learning. How? Why? Because here the question itself says that place an agent in any one of the rooms and goal is to reach the outside the building. Yes, when you see a word agent, yes, definitely it comes under the reinforcement learning. I already told you reinforcement learning, we have two algorithms. In that one is the Q learning algorithm. With the help of Q learning algorithm, it has to reach to room 5. If it successfully reach, he will get the reward. Otherwise, that particular agent is going to get the punishment. So now other type of learning, that is semi-supervised learning. It is the name itself indicates semi-supervised. It's a combination of supervised and unsupervised. And these algorithms represent a middle ground between supervised and unsupervised. Not formally defined as fourth element of machine learning, but it combines the aspects of former two into a method of its own, that is supervised and unsupervised. So it combines the aspects of these two, and it was semi-supervised. So when it comes to supervised learning, we know that we are going to give the labeled data, but whereas coming to the semi-supervised learning, as we have it is supervised and unsupervised, so some part is labeled and some part is not labeled. So here you can see this is labeled data, and this is means most of the data is unlabeled and some part of the data is labeled. So see here, so partially labeled, mostly unlabeled. So a combination of supervised learning model and unsupervised learning model, that gives the semi-supervised learning model. And these are some of the practical applications of semi-supervised learning, like in speech analysis, okay, in internet content classification, and some protein sequence classification where in DNA strands, okay. So in that also this rise of supervised machine learning has been eminent in this field. So this is all about the learning. We know that machine learning making computers learn and act like humans by feeding data. See, ordinary system with AI, machine learning learns, predicts, and it is going to improve. And then supervised, we know that labeled data, these are the labels, will train the model, and it is going to, when you give the new data, it is going to predict the output, that is supervised. Unsupervised, just raw data we give, that is unlabeled, it is going to interpret, and the algorithm it is going to process, and then it is going to give the output. And coming to the semi-supervised, there will be unlabeled data, there will be a labeled data, then we are going to give a classifier, and it is going to give us the output. Coming to the reinforcement learning, where agent learns how to behave in an environment by just performing the actions, and then you are going to see the results. So this is environment. If you take the action, then the agent will go to the new state. This is what the reinforcement learning. Thank you.